there. This is Robert, your math coordinator, coming to you live from the MCS Distance Learning Campus, located in here, beautiful Brooklyn, South, New York. I'm here to talk to you today about a math activity that you can do at home with very few materials, and that is worth exploring, and it goes back pretty far, a little over 100 years, to Germany, to a mathematician named Issai Shur. And Issai Shur lived from the end of the 19th century to about the middle of the 20th century. And he was a mathematician, and he worked in number theory. And here is a very simple problem that he stated, which turned out to be much harder than he imagined. Okay? And we call it the least sum partitioning problem. So here's how it works. I have the numbers 1 through 20 laid out on the table in front of me. And I put them, each one on a separate card, right? Which I made from just some cardboard I had lying around the house. And what we're going to do is we're going to take the numbers in order. So 1, 2, 3, well, I'll start with 1, 2, 3, 4, and 5, for example. And we're going to put them in these bowls. And we're going to make sure that no two numbers in the same bowl add up to a third number in that bowl, right? And I'll give you an example. I'll take 1, and I'll put it in here, okay? And I'll put 2, and I'll put it in here also. If I put 1 and 2 in this bowl, like this, then I can't put 3 in here, because 3 is the sum of 1 plus 2, okay? Pretty simple so far, right? So I take 1 and 2 and put it in this bowl, 3 goes in this bowl. Question is, what should I do with 4? Well, it turns out I can put in either bowl, right? This one has 1 plus 2, this one has 3, I'll put it in here. Now, if I put it in here with 3 and 4, I know that I can't put 7 in this bowl later on. So I should be planning ahead, but whatever. Okay, here's the number 5. I could put 5 in either bowl. Where do you think I should put it? Okay. Here is 6. Okay, now 6, I can put in this bowl because I know I have 4 and 3, and 4 plus 3 is 7. But I can't put 6 in here because I put 5 and 1 in here. And 5 plus 1 is equal to 6. So I am forced, in some cases, I don't have a choice, I have to put it here. 7, well, I know that I put 4 and 3 in here, so 7 can't go in here. On the other hand, I have 5 and 2 in here, which is also 7. So what does that mean? Do I just put 7 to the side? Well, it means I have to go back and start rearranging my numbers. So maybe a decision I'd made, maybe this 6, right, should go somewhere else. Maybe I should say, okay, I could put the 6 in here, but I can't put the 6 in here. I already have 5 and 1. So I may have to go back and change it. I may have to start all over. As you can see, this could be very frustrating. Not yet. I will tell you right now, with 2 bowls, you will not make it to the number 20, and you do have to go in order. You'll get pretty far, but you won't get to the number 20. There's a mathematical reason for this. You can look it up on the web. Issai Shur is his name. The least sum partitioning problem is the name of the problem. Now, the fun doesn't stop there, right? I mean, the question is, I want to see how far can you get, right? But the fun doesn't stop there because Issai Shur started playing with this problem and he started asking other questions. What if I didn't go in order? What if I were allowed to say, well, I can't put 6 in the bowl, so I'll just skip that, but maybe I can do 7. Maybe I can put 7. Actually, I can't put 7 in here because I have 4 and 3 in here already. So that's another way of approaching this. You could also say this. What if instead of 2 bowls, I have 3 bowls? How far would I be able to get then? What if I had 4 bowls, right? So as you can see, this problem is a really great way to get your hands dirty and really dig into a problem and just see what can happen when you're doing it, okay? So try it out. You know, there's not lots of materials here. It could provide a great deal of fun and maybe a little bit of frustration on the side, but who doesn't like a little bit of frustration? I mean, you know, you're at home anyway, you might as well ramp it up a bit. So try that out. Remember, it's Issai Shur's least sum partitioning problem. And write back to me. Take pictures. Show me what you figured out. I'd love to know. So be well, stay safe. I miss you all. Peace.